and we're going to determine the average rate of change of a function. So new vocabulary: increasing, decreasing, constant, maximum, minimum, extrema, and average rate of change. Those should kind of be okay. You should be okay with those. Oh, secant line. Alright, so the first thing we're going to look at is increasing and decreasing in constant functions. So on this top block we have an example of an increasing function. As you go to the right, it's going up. Decreasing, as you're going to the right, it's going down the y-axis. And then a constant function is remaining the same on that interval. Questions there? Do you want time to write that down? Or are you okay? Alright, so we're going to use the graph of the function x squared minus 4 to estimate intervals to the nearest 0.5 unit in which the function is increasing, decreasing, or constant. Alright, so looking at the graph, where is the function? Let's start with decreasing. From where to where is it decreasing? Is this going to be a bracket or a parenthesis?
Bracket.
Why a bracket?
Because after that, after 0, it increases.
And then it's increasing from where to where? Okay, so they put parentheses for there, and technically at 0, it's neither decreasing or increasing, because what was 0 on that graph? The vertex. And what does the vertex indicate? Well, it's the line of symmetry, but what are we doing? What's our graph doing at 0? At that point, it's changing direction, so it's from going down to going up. So you're going to use open. And they made a graph. There you go. All right, so looking at this one. So this one's trickier because we have the wiggle in the middle. So where are we going from? Where to where are we decreasing? All right, so yeah, we're good. All right, so we'll do a parenthesis, and so we're decreasing here to here. So then at this point, we're at a vertex. So at that point, our graph is changing direction. And so at negative 0.5, what are we doing?
Increasing to 0.5.
Alright, so at that point, we're at another vertex. And so as we, from here, we're going to decrease. This one's positive. So as we're moving to the right. But the limit, as we go, as our x value increases, as x approaches positive infinity, what's happening to our function? It's approaching negative infinity. All right. All right, so That's what we came up with. Any questions on increasing or decreasing? All right, so take a second to look at this. In this one, as we're looking at the graph, which one of these A, B, C, or D supports what's going on here? I think it's supposed to be a negative one. Now, what's the difference between A and C? So this one, it just says it's increasing on 2 intervals. We're saying C. Now, what can we eliminate? What can you eliminate? Problem solve. It's a multiple choice, so use your logic to narrow your options. Which ones can we eliminate?
A for sure.
A for sure, because if it's increasing the whole way, that would be a line, right?
Yep.
What other one can we eliminate? D, because that one's just decreasing. So now you went from a 25% chance to a 50% chance. That's much better odds. So now looking at this, so now all you're looking at is, are you increasing or decreasing on that first interval?
Decrease.
We're decreasing. You always read a graph from left to right. So we're going down. And so we're decreasing and then increasing after the vertex. All right, so now we're going to look at relative and absolute extrema. Extrema is like the low is where it's your high and low points. So a relative maximum is the greatest value in a certain area, not necessarily for the entire graph, but just in an area of the graph. Then the relative minimum is the lowest point, in a certain area. I think this is supposed to say absolute maximum, and this should say absolute minimum. Because the absolute maximum is the highest point for the entire graph, so over the entire domain. Oh, it says it there. Never mind. No, that's it. This should be absolute maximum, and this should be absolute minimum. Alright, and then the absolute is like, if you're looking at your entire domain, it's the tallest point ever. And then your absolute minimum is your lowest point on your entire domain. So for these, this could be, if you're just looking at this area, is a relative maximum. But if you're looking for the whole area, that's your absolute maximum. It's the tallest point there. Questions? All right, so we're going to estimate and identify extrema of a function. So what are the maximum points on our graph?
The size negatives? So it'd be
But-
-8.
So yeah, just like on this graph, what are the highest points, not including the infinities?
Oh, it's a 16. So I was like, why 3?
So we have a tall point here, right?
Yep, and a -8 there.
And then we have a low point here. So this graph has a relative maximum at, what is this, 2?
Wow.
So 2, say 14. And we have a relative minimum at, and this is -8. All right, so we have a relative max here and a relative min here. And so within our domain there. And so, okay, so then looking, so we had our relative minimum and our relative max. And then because we don't have, it's going on forever, so if we expand it, you know, our maximum is going to continue to grow and our minimum will continue to grow. And then they're showing that it keeps on getting bigger. Was that the same example or a different one? All right, so looking at this one, we have our graph here. So looking at our A, B, C, and D, it says estimate and classify the extrema for the graph. So where do we have a maximum point up here, and then a minimum point, relative minimum there. So which one of these best describes the graph?
If they don't have any numbers, do we just assume they're going by ones on the
Yes.
graph?
This one they're going by 1. Because if you plug in 0, you get 1.
Oh,
All right, so what's this point here?
always.
All right. So that's a relative max. And then our relative min is here. And so that is at 0, positive 1, correct? So here this is saying that we have a relative min at -1, 2, and a relative max at 0, 1.
So is
So-
that
So
x equals -1? That means that -1 goes in the x spot.
Right, this
and
is
then
the
2 goes in the y spot.
Yep.
Okay, now I know everything.
All right, so does this doesn't match the coordinates that we have, right? So this one's saying that we have a relative max of 2 at x equals -1. Well, that works. That matches what we have. And a relative minimum of 1 at x equals 0. That matches what we have. And it says there's no absolute extrema. Okay, so that one maybe. There's a relative max at 2, -1, and no relative minimum. Well, we came up with one, so we know that's not it. And so this one says that there's neither. So it looks like B is the one that fits